Dear students, today let us discuss few aspects of your physical chemistry unit 4. In that, we will going to discuss about the electrosynthesis. Myself, Dr. Ganesh Acharya, Assistant Professor, Department of Chemistry, IDSC Government College, Chikmagaluru. What actually meant by electrosynthesis? It is the electrochemical synthesis is the use of electrical energy to bring about a chemical change or chemical reaction using electric current. It is to replace the toxic costly chemical reagents. This allows a cleaner and cheaper synthesis method which has a greater production efficiency and at a reduced cost. In other words, synthesis of chemical compounds by means of electrolytic oxidation or reduction is also called as electrosynthesis. Over the past 25 to 30 years, the use of electrochemistry as a synthetic tool in organic chemistry has increased remarkably, and more than 100 electroorganic synthesis processes have been used in the industrial scale, and such examples include the reductive dimerization of acrylonitrile, hydrogenation of heterocycles, pinacolization, reduction of nitroaromatics, and Kolbe reaction, and so on and so forth. Now, let us just have a look at the difference between the electrosynthesis and conventional synthesis. In the conventional synthesis, we all know that a large quantity of organic solvents are used, but in the electrosynthesis, it is not so, because the only reagent used in the electrosynthesis is the electrons. So therefore, there will not be pollution in case of electrosynthesis because we are not using any organic solvents. And second thing is, it doesn't cause pollution in case of electrosynthesis, but in case of conventional synthesis it causes pollution because we are using large quantity of organic reagents or solvents. And in the conventional synthesis, the separation of products is difficult because it includes several side reactions and impurities and so on. But in the electrosynthesis, it is not so. The separation of products is easy because it includes only oxidation and reduction reactions. So it can be easily separated from one another. And in conventional synthesis, side reactions are more, but in the electrosynthesis, side reactions are very few, and in some cases, there will not be any side reactions. And in the conventional synthesis, the control over the reaction is difficult because, as I said, it includes several organic solvents, and it depends upon temperature, and it depends upon concentration of the reagents and time duration of the reaction and so on. So control over the reaction depends upon many factors, so hence it is difficult to control the reaction. But in case of electrosynthesis, actually it depends on only few factors like the source of electric current and the oxidation and reduction reactions, hence it will be easily controlled. The first ever reaction by means of electrolytic reactions is known as Kolbe reaction. Actually, it is an anodic reaction where we are converting the alkali metal salt solution of a carboxylic acid into an alkane. So, as I said, it is an anodic reaction. So, it includes these two steps. First is this is actually an alkali metal salt of carboxylic acid. It loses two electrons to form two radicals. So upon releasing carbon dioxide, so these two radicals are combined together to form an alkane. It is an anodic reaction, as I said, and it also includes the opposite reaction, that is cathodic reaction, which is actually the direct hydrogenation, that is reduction reaction. It includes these four steps. So that is R plus E to form R dot, R dot plus H plus to form RH dot, RH dot plus E minus to form RH minus, RH minus plus H plus to form RH2. So there are two electrical steps where the addition of electrons. There are two chemical steps which includes addition of H plus ions. So electrochemical reactions involve the motion of electrons, and the fundamental event in the electrodic reaction is to exchange the electrons at the electrode electrolyte interface. The electrified interface is called electrical double layer. It is an important part of all electrochemical reaction, and it is a narrow region under the influence of the enormous electric field. So that is called as electric double layer, where actually the electrochemical reaction occurs. So as I said, it includes the enormous amount of energy that is actually called sometimes as activation energy in this range, which will bring about these type of reactions. So the electrode potentials to bring about some reactions are given in this page, where you can see that the these are few reactions starting from -3 to +4 volts to bring about some certain electrochemical transformations. The practical essence of any electrosynthesis mainly consists of transfer of organic species from the electrode surface, I mean, from the bulk to the electrode surface. This is the first step. And second step includes exchange of electrons between electrode and organic species. It may include, adsorption of the intermediate or the product on the surface of the electrode. And in the third step, actually, it includes the removal of primary products from the electrode surface. It is actually desorption. So the steps involved in the electrosynthesis is transfer of organic species from the bulk to the surface of electrode, exchange of electrons between electrode and organic species, that includes adsorption of the species, and third is removal of primary products from the electrode surface, that is actually desorption. So this is a general example. Here you can see A plus B form an intermediate to form C plus D. These are the products, that is A plus B gives rise to C plus D. Now if it is reduction reaction, A plus E to form an intermediates AE minus to form a cathodic product here upon reduction, that will be C. At the same time there occurs oxidation reaction upon losing an electron from one of the reactants to form B plus, which undergoes anodic reaction to form the final product D. So the overall reaction will be A plus B gives rise to C plus D. So this electrochemical reaction depends upon electrochemical activation energy E dash as a factor of e to the power minus E dash by RT. It can be achieved by varying the cell voltage. The basic or fundamental experimental setup is as shown in this figure. Here you can see that this is a general cell, that is generally a galvanic cell, a potentiostat which is actually source of electrons, and generally there are two electrodes, one is cathode and the other one is anode. A good electrosynthetic conditions use a solvent and an electrolyte combination that minimizes the electrical resistance. Electrodes are selected which provide favorable electron transfer properties towards the substrate while maximizing the activation energy for side reactions. So this is about the fundamental experimental setup. So let us discuss in detail about the experimental setups in the coming classes. So these are few references you can go through. So dear friends, this is a brief introduction about the electrosynthesis. In our future classes, we shall discuss in detail about few examples as the electrosynthetic method. Thank you.